let's look at the information for your test 6 coming up on Fantastic 5. The first question that you need to focus on has to do with locating these numbers on the number line. I notice right away that I have 2 improper fractions, and these improper fractions mean that there is at least a whole hiding in there. So I just started with the basic number line. I can extend it if I need to, and I probably will. So the one I know to do right away is the half, because a half is in between 0 and 1. So this is where your B would be, right here in between 0 and 1. It's halfway in between. Okay, I've done that one. Now I have my 2 improper fractions here. I know that in this 4/3 there is a 3/3, or a whole, hiding in there. I know that because I know how to divide it, and I also know that if I took out 3/3 out of that portion right there, there would be a third left. But if I divided it the way that I'm confident that I will always get the right answer, I divide my bottom into my top always, and my denominator goes into my numerator 1 time, and I'm left with 1. Not 1 part out of whatever you make up, 1 part out of your divisor. 1 part out of 3 is left over. So 1 1/3. If I break this group up into chunks of 3, it might go somewhere right around here for our third portion. So that would be 1 1/3, or your number A, or I'm sorry, your letter A. And then to do the same for our other one, I know that there are two halves hiding in that 5. They're actually 2 groups. 2 goes into 5 2 times. 2 times 2 is 4, and I'm left with 1/2. So 1 over my divisor is 1/2. I know that I have 1 part out of the 2 left over. So 2, need to extend it out. In between 2 and 3, we have our 2 1/2, which was C. That's the way your numbers would be lined up on your number line. For number 2, you can see that the gray part is rotating clockwise about that rectangle. So if you continued rotating it clockwise, you would take this, goes there, and then it's going to be all the way over. Yikes, sorry about my bad image. Over on the opposite side. You can also think about it as every other one, it's rotating. That either way is fine with me, but clockwise is a good way to think about it. If these are each a centimeter apart, count it like a number line. Point A and B are 1, 2, 3, 4, 5 centimeters apart. Centimeters is important because if they give you that unit, you must include it. For number 4, the area of a rectangle is. They give you the is. Is means equals. Don't forget it. It's important. They give you that it equals 30 centimeters squared. We know that the area of anything is length times width. And so we know that the length is 5, but we don't know the width. Anytime we don't know anything, substitute it for a variable. That looks funny right there, side by side, that x and that x. So I would substitute it for a different variable. I'm going to pick a very wise variable. I'm going to use that w. It doesn't really matter because a variable is just that. It's a substitution for something you're trying to figure out. 5 times w equals 30. Well, 5 times what equals 30? It's a division problem. 5 times 6 equals 30. So 6 centimeters is your best answer for that problem. For number 5, what would the scale look like if you were to graph that following group of data? I would count by tens. Scale indicates basically what your quote-unquote, let me type it, counting by. And I think that the best way to use this data would be to count by tens, to go from 0, always from 0 in a graph, to 5, to 10, 15, 20, 25, 30, 35, and 40, and then 45. That should give you your whole y-axis data. If I rotate this and I put it just like you would have it up in your y-axis, except you would write it the right way, it would look something like that and spaced out and much prettier. But counting by fives, I think, is the best way to do that for that problem. For number 1, write this number in standard form. Pick out your big keys here. You have a lot of helpful hints. Some of the helpful hints is this word and. It means a decimal. When you hear your number words, 1,000, 100, you kind of get some good stuff going there too. This number I'm going to break up right here, 1,000, and I'm going to do that because when I hear 1,000, I know that I'm going to do my 1 and my comma to represent the 1,000. 463. I'm just going to write 463. And means decimal. 800ths. Well, if I put the 8 right here, that 8 would be in the 10th spot. So I have to save my 10th spot because they didn't speak to it, and they said that they were 8 of the hundredths. That puts my 8 in the hundredths category. So that's the best way to write that number that you see right there. For your next one, write an equation to represent a number, again, a number divided by 3 is 9. So any number, I'm going to pick M because for some reason it sounds like a really great number. Maybe it's because it begins my first and my last name. A number divided by, well, I can't really do that sign without writing it, divided by 3. Any number divided by 3 equals 9. There is a set number that's going to work in that equation. What number divided by 3 does equal 9? You can use that reciprocal information, that inverse operation that we kind of talked about briefly earlier in another page. But if I multiply these two, since there's a division sign there, and I get my 27 and plug it in for M, it will work. 27 divided by 3 equals 9. That's not part of it. You don't need to know that, but you do because it's important. The way you write this equation is M divided by 3 equals 9. An equation is always going to have that equal sign, meaning that they're balanced. For number 3 on number 58, they ask if these two figures are congruent. Yes, they are both squares, but no, they are not congruent. Congruent means the same size and the same shape. Remember, those things have to be there, size and shape. The shape's there. We got that checked off. We can check that off of this. But the size, one's smaller than the other, so they are not congruent. We would call them similar. For number 59, what customary unit of measure would you use to measure the amount of water in a swimming pool? The customary is what we use in the United States. It's what nobody else in the world uses except for us, so y'all just feel very privileged about that because it makes your life a lot harder. You have to learn 2 systems. But we would probably use gallons for that. Gallons would be the best answer for that problem. And I'm not going to write it all out like that, but gallons would be the best thing to use for a swimming pool. If you're talking about kilo this, kilo that, meters, liters, and grams and all that, we're talking about the metric system. But this one asked for the customary system, the one that we use in our customary system, which is the gallons and so forth. To construct this line graph, I am not going to do it for you. But any line graph is going to be set up in a similar manner. You're going to have your time frame down here. So you're going to have your months, your January, blah, 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 blah. And then you're going to have your your amount of money up here. The bottom piece of data in this, the smallest piece of data that I'm seeing right now is 2,000. So 2,000 would be your smallest. I would go by thousands. I would go start with 0, 1,000, 2,000, 3,000, 4,000, 5,000, and I would go all the way up until I get to 15 for my December sales. Christmas! They're making lots of money in that toy store at Christmas time. I hope this has helped you make a 100 on your quiz. In fact, I think I have something else I can show you about that line graph. I think I actually have it on here to help you, so stay put. I'm going to pause you. Okay, so it's a little different, but same idea. You're going to count your numbers this way and your months this way and connect your dots after you plot your points, and that will give you your line graph. I hope this has helped you, and good luck on your quiz.